Greetings and welcome to the basement. In this quick video, I'm going to take a look at the save game system that I created. It is an extremely simple, very basic save game system. Does not do a lot of things, but it gets the job done if you need just a quick, very simple way to save data. Upon importing the package in, you will just have these two loose script files, game logic and save data. Of the two, you only need save data. Game logic is just to produce some demonstration. To use it, all I really need to do is create an empty game object, attach game logic to it, and then as a final step, come up to Tools and make sure that I have a Streaming Assets folder created, which is where it's hard-coded to save the file to. You notice I just got some basic junk data effectively in here. And if I hit the space bar, sample data goes up each time I hit the space bar. Shockingly complex mechanics. And if I stop running, of course, since sample data changed over the course of the runtime, it goes back to 0. But when I hit run again, it reloads the sample data. And of course, if I get to the point where I've decided it's like, okay, you know what, I need to reset my data, very convenient option here just to delete the saved data. And sample data is now back to 0, like it was supposed to be. How is this doing this? Well, it's basically creating a JSON file. Now, due to the fact that Streaming Assets is a very special folder, it's not going to show up here automatically. If you're not familiar with Streaming Assets, this folder basically says, I am not going to do anything to these assets. I'm not going to process them. I'm not going to look at them. The only thing Unity is going to do to these things is copy them over when you make a build. That is it. And as such, it's not scanning here constantly for new files. So the fact that it was created during runtime means it's not going to show up. The next time you import something or force a refresh, it'll show up. Or you can right-click and say refresh, and there it is, because I'm being blind. And after refreshing the project folder, you will see the file. It is just a basic JSON file. And if you open that up, and that's all there is to it. Let's take a quick look at the code. In terms of using it goes, as you can see here, it's well commented. For game logic here, all it does is on awake, it attempts to use the static method load file to load the save game data. If that fails, it just creates a new instance of save data. And if it doesn't fail, then it takes the result and uses that to remember the information. At that point, it's like any other class. If I need to update or change the information, I just simply reference save data and the variable that I want to change. This can be as simple or as complex as you want it to be. And then just as an example for saving it, I hook into the onDestroy method for game logic, and I've included a save on destroy flag that you can turn on or off for the save data. To see, it's like, okay, well, once this gets destroyed, do I want to automatically save my data? This is useful if you want to ensure game data is saved when the user tries to quit the game or scene changes, things like that. And then I just call save to disk, which, as I mentioned in the comments here, obviously is not restricted to just here. That can be called anywhere. As far as to how this is implemented, of course, we need to be serializable. Otherwise, JSON is not going to work on this. These are just sample variables. They don't matter. They're just there to prove that, yes, this is working. This one isn't a sample variable, although I suppose you could remove it if you really wanted to. It's still saved, however. And that, this is the Boolean flag I use to determine, well, should we save on destroy? Let's take a look at loading first, and we'll go back to saving. Again, fairly basic. We attempt to verify whether or not the savedata.json file already exists. If it does exist, and I'm just using basic system.io stuff here. If it does exist, well, then I create a stream reader to that file. I read the entire file to the end and store it in a string. You always want to close your files, of course. And then I use Unity's, this is from Unity's, JSON utility to save the data. If you would like more complex JSON functionality, there are several different C# JSON libraries out there that are open source for you to grab. And then I return the result. Of course, if this file does not exist, the default value of result is null. So this should either return null or an instance of saved data. Saving to disk, again, pretty simple. I create a path to savedata.json. Now, this does make the hard-coded assumption that the streaming assets path has been created. So make sure you do not skip the step in the editor of creating the streaming assets path. Upon creating that path, I then create the JSON data by using the JSON utility .toJSON. Remember if I very explicitly pointed it out. From JSON down here, so it takes a string of data that is in JSON format and creates an instance of the appropriate class here. This can obviously be whatever you want. And toJSON takes an object and serializes it to a JSON string. I then take, now that I have my path and I have my string, I open up a stream writer based on that path. I open it in overwrite mode, not append mode. I write my data, and obviously need to close my file to make sure that everything's all nice and tidied up. There are a few utility items on here. Scroll down to the bottom where you see the if Unity editor. If you've not seen this before, this is a compiler directive. In other words, this is giving directions to the compiler. You cannot make production builds with stuff from the Unity editor. It does not work. And since I am using the asset database here to create the folder, and I'm also using the Unity editor namespace for the attribute here, but mainly the use of the asset database, I cannot have this included in a build, and so I put the compiler directive around here instructing it that unless the Unity editor flag has been turned on, don't include this. And that is it. Like I said, it is a very basic system. You only get the one save file, and you do have to know ahead of time what data that you want, because all of that data has to be declared in this class. They do not have to be public. That just makes it so that you can see/edit the information in the inspector. But all information that you want saved has to be defined as a class level variable in save data. But in terms of setup and getting it running and working, it is very fast because of its simplicity. And I'm unsure if this would necessarily hold up to, say, production level requirements. Especially, I know it wouldn't hold up in a web development or a Android development environment, because no attempt here is made to accommodate for the file systems for those build targets. But if you need just a simple, quick save system for a PC target build, this will work. And that's all I have for this video. Just showing off the basic save system and quickly going over the code. And so, until next time.